Welcome! Okay, this is a no frills video. I don't have any students in here. I'm just teaching you viewers. Okay, this is a quick review of right triangle, the whole right triangle chapter. So we're going to go over Pythagorean theorem, we're going to go over trig, and we're going to go over special right triangles. Okay, so we'll start with Pythagorean theorem. Okay, this is mainly for your SOL. So your SOL problems are not going to look like this. Okay, it's not going to give you a right triangle where you're given two sides and asked to find the third side. That's when we use Pythagorean theorem. Okay, you use Pythagorean theorem when you're given two sides in a right triangle and you're asked to find the third side. This will always be embedded in another problem where you have to use Pythagorean theorem. Okay, but you need to know Pythagorean theorem and when to use it. Okay, so if you are ever doing a problem, and sometimes it'll look like a circle, you know, it'll be something inside a circle, or it could be inside a pyramid. Okay, we don't know where it's going to be, but it's going to be in probably another diagram. Okay, where you have a right triangle, and you're given two sides, and you're asked to find the third side. Okay, so Pythagorean theorem, C squared equals a squared plus b squared. C is always the side that is opposite from the right angle. So here is C. The other two are interchangeable, A and B. A and B, interchangeable. Okay? So in this right triangle, this 18 has to be C. So we write our equation, we'll write C squared equals A squared plus B squared. I like to write C squared first, just because, for other reasons, okay? So, but in this example, it has A squared plus B squared first, perfectly fine, okay? You plug in, looks like they plugged in 8 for A, and we're trying to find B. So, look through that. This should be pretty basic. Everybody should be good. Okay, let's move on. All right, so trigonometry. Okay, this is where most people have trouble. Okay, so you need to have the trig relationships memorized. Okay, and I don't care how you do it. Okay, when I'm writing mine, when I learned back, in high school, I memorized my relationships this way. Okay, but most students nowadays like to use SOHCAHTOA. The sine relationship is the opposite over the hypotenuse. The cosine relationship is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. Okay? You have to have that memorized. I can show you on your formula sheet something that gives you can use your formula sheet, but it doesn't use opposite, adjacent, and hypotenuse. It uses X, Y, and Z, and some students get confused by that. So I don't like to confuse the students. I will show that to you, just not in this video. Okay? But you are going to use trig when you have problems like this. You've got a right triangle, okay, and you are given the length of one side and the measure of another one of the angles, and you're asked to find the measure of the length of a side. Okay, so here, right triangle, you're given the measure of one of the other angles, you're given the measure of only one side, and you're asked to find the length of another side. That's what this says right here. Okay, so you might want to read this over, press pause, and let that sink in for a minute. Okay, this could be embedded in another type of problem. Okay, so what do? Well, here's our angle that we're referencing. In relationship to this angle, the two sides that we have, or the one that we're looking for, x, is opposite this angle. And this side is across from the right angle, so it's the hypotenuse. Which trig ratio uses opposite and a hypotenuse? This is where the memorization comes into play. That's sine. So the sine of 36 degrees, and everyone's writing this down, equals this relationship, opposite over hypotenuse, or right here, opposite over hypotenuse, x over 8. Now, this is a number. If you had a proportion in Algebra 1 where you had a number equals an unknown over another number, what would you do? Okay? You could either think of it as a proportion and cross multiply. But either way, you're going to be multiplying this x by 1. So really, all you need to do is multiply these two numbers together. That gives you the value of x. Okay? That's when your unknown, need to make a larger eraser. That's when your unknown is in the numerator. Okay? So, we'll take out our calculator. I prefer to do 8 times the sine of 36 because if you put into your calculator the sine of 36 and you forget to close the parentheses and then you do times 8, well now you're going to have a completely different answer. So I prefer you put that 8 in front. Then you don't have to worry about whether you close the parentheses or not. Because if you don't close the parentheses, you get the same answer. Okay? The calculator has to be in degree mode first. So let's go to the calculator. So, mode, my calculator right now is in radians. So I need to change it to degrees. Okay, now degrees is highlighted. And I've done this one forever. All right, clear? All right, so we go back up to our problem. We are multiplying 8 times the sine of 36. 8 times sine 36. I'm going to close the parentheses. There we go. Okay, so that's the length of our side. And it'll tell you how to round, and on your SOL, you don't have to really worry about that. So we got the length of this side is about 4.7, what are the units? No units. Okay, so I'll just write units. Not squared, units. I'm not dealing with area. All right, let's go to this one. Referencing this angle, this 5 is adjacent. This side would be opposite. We don't have that side and we're not looking for that side. We have the adjacent side and the hypotenuse. Which trig ratio uses adjacent and hypotenuse? Cosine. So we're going to use the cosine of this angle equals adjacent over hypotenuse. Now, our unknown is in the denominator. In Algebra 1, what would you do? Okay, you would, and I want to just show you this, okay, and then I'm going to show you a shortcut. Okay, what you would do is you'd multiply. You do y times the cosine of 72 equals 5, right? You'd be cross multiplying. This is like, if this is over 1, it'd be 5 times 1, that's just 5. And then you got to isolate your y. We're looking for y. So you would then divide by this number, the cosine of 72, both sides. Okay? So, you take out your calculator and do 5 divided by the cosine of 72. So we got 5 divided by cosine 72. My calculator is already in degrees. Once you change it to degrees, it should be good until the memory is cleared. When you get into the SOL, it's going to be in radians, and you're going to have to change the mode yourself. Okay? So, close parentheses, press enter. 16.2. Okay. We look at our question, we make sure that sounds like a reasonable answer. I look at the diagram, that looks pretty reasonable. Okay? So y is approximately 16.2. Now, I showed you this because I'm about to show you a shortcut. You don't have to go through all this. Okay, maybe I can just write over this in white. Can I do that? Yes. Shortcut, right over here. Okay, so I'm going to rewrite this proportion. Okay, when your unknown is in the denominator, okay, this is like a proportion, right? You're going to end up multiplying the y by the cosine of 72. Those two numbers can change locations. Okay, so I'm going to rewrite this. I'm going to leave the 5 where it's at. Okay, I'm going to write this as y equals 5 over the cosine of 72. Now look, we just bypassed all this algebra by doing the shortcut. So if your unknown's in the denominator, switch them and you just divide. Okay? If your unknown's in the numerator, you just multiply. Let me say it again. If your unknown is in the denominator, you just switch them and divide. Divide. If your unknown's in the numerator, you're just going to multiply the two numbers. Done. Okay? Move on. All right, inverse trig. Most of the time, since the inverse trig problems they're extremely difficult, most of the time you'll see them looking like this. Okay? So there'll only be one unknown at a time in an SOL problem. Okay? So, if you are given, it's a right triangle, you're given the length of two sides, but they're not asking you to find the length of the other side, because if they did, then you'd use Pythagorean theorem, right? They're asking you to find the measure of an angle, okay? So, what you're going to do is, same as before, okay? You're going to use trig. Our calculator's already in degree mode, okay? So, we're referencing this angle. This 5 in relationship to this angle is opposite, and this is our hypotenuse. So we're going to use, which trig ratio is that? Sine. Okay, so the sine of x, all right, I'll put x degrees, equals opposite over hypotenuse. And I'm going to write that like this. 5 divided by 13, because that's how we're going to type it in your calculator. Okay, now, watch what happens, okay? Our unknown is inside another function. So we have to do the opposite operation of this function to isolate this x. The opposite of sine is the inverse sine. So what we're going to do is we're going to multiply both sides of this equation by the inverse sine. You're not going to do this every time. I just want to show you why you're using inverse sine, okay? So you multiply both sides. Those are going to cancel. So what you'll have is x equals the inverse sine of 5 divided by 13. Break out your calculator in degrees. Okay? Inverse buttons are in blue right above the sine, cosine, and tangent buttons. So you're going to press second and then whatever trig ratio you need. Okay? So inverse sine of, was it 5 and 13? 5 divided by 13. 5 divided by 13, close parentheses, enter. There's the measure of your angle, 22.6 degrees. So x is approximately 22.6 degrees. Okay? Now the other one, since we're practicing trig, I'm going to use trig, but at this point, if you know, if you're just solving this in class, okay, and if you know this is 90 degrees, the measure of this angle is 22.6 degrees, you can just subtract those both from 180 to get y. But since we're practicing trig, we're going to use trig for the next unknown. All right, so now we're trying to find y. So referencing angle y, now this 5 is not opposite y. It's right next to it, so it's adjacent. Adjacent. The 13 is also adjacent to the y, but it's across from the right angle, which makes it the hypotenuse. So, which trig ratio uses adjacent and hypotenuse? Cosine. Okay, so now I'm going to show you, I'm not going to go through all this. The inverse cosine of 5 over 13 should give us the measure of that angle. You can go through all that if you want, okay? So, inverse cosine, 5 divided by 13, close parentheses, enter. 67 degrees, 67.4, that makes perfect sense because if you add those two numbers, they add up to about 90. So that's about right. Okay, so 67.4, so y is approximately 67.4 degrees. Okay, so if they ask you to find, if your unknown is the measure of an angle, you need inverse trig. All right, last but not least, special right triangles. This special right triangles is an optional shortcut, okay? If you get a problem that has multiple choice answers, and they all have radicals in them, and you have completely forgotten these relationships, you can use trig, get your answer as a decimal, and then figure out which of those answers is equal or pretty close to your decimal, and you can figure it out that way. This is an optional shortcut, okay? But I'm just going to go over it very quickly with you. The relationships, and I've shown you this in class, okay? And you can use Pythagorean theorem if you want. If you know the length of these two sides, you can go through and figure out the third side. Someone's already done that for you and said, if we've got an isosceles triangle here, okay? So we've got a 45, 45, 90 triangle. These angles are 45 degrees, and this is a right triangle. The relationship between the two sides that are congruent and the hypotenuse is that the x, or the length of the congruent side, times the square root of 2. Okay, I've showed you that. You can get that using Pythagorean theorem, but I'm not going to do that right now. But if you can remember that relationship, it's a shortcut. So, again, you can do Pythagorean theorem and get the same answer. Or you can memorize this shortcut and know that the length of the leg times the square root of 2 is your answer. Okay? This one is the same as this one, except for they are giving you the length of the hypotenuse, and they're asking you to work the opposite direction. If you have to go from the leg to the hypotenuse by multiplying by the square root of 2, you're going to use the opposite operation to go the other direction. So you're going to be dividing by the square root of 2. So they give you 10. They ask you to find the length of the congruent sides. We know this is a 45, 45, 90 because these two sides are congruent. Okay, so we have to take our 10 and divide by the square root of 2. We can't leave that as our answer. We don't want a radical in our denominator. So we have to multiply by special 1. Look, I love special 1. Okay, so 10 square root of 2 over 2. This 2 goes into 10 evenly, so that's just 5 square root of 2. Okay, 30, 60, 90. There's one extra relationship. The relationship between, and this is 30 degrees, the side that's opposite the 30 degrees is the shortest side, right? The longer side, the long side, is across from the 60 degrees, and the longest side, the hypotenuse, is across from the 90. The relationships are 1, 2, square root of 3. Whatever this length is of the short side, everything revolves around the length of the short side. The length of the short side times 2 gives you the hypotenuse. The length of the short side times the square root of 3 gives you the length of the long side. Okay, a lot of people get these numbers confused. But if you look at the numbers 1, 2, square root of 3, is that the order from least to greatest? Some people think it is. But then when you actually look at it, if you did square root of 3 on your calculator, it's going to be 1 point and some stuff. It's less than 2. Okay, so 1 is the short side, square root of 3 is the long side, and 2 is your hypotenuse. Okay, so when they give you the short side, okay, here I know this is the short side because it's across from the 30 degrees. Okay, so I immediately put a 1 there. I'm going to put a 2 next to my hypotenuse to remind myself that I'm going to be taking that and whatever that is and multiplying it by 2 to get the hypotenuse. And then I put a square root of 3 on the long side, just to remind myself. Now I've got a visual. Okay, so if the short side is 5, the hypotenuse is just going to be 10, right? And the long side is just going to be 5 times the square root of 3. Where it gets tricky is when they don't give you the short side, and you have to do the opposite operation. So if they give you the hypotenuse, you got to divide by 2. If they give you the long side, you got to divide by the square root of 3, because you got to get that short leg before you can get anything else. So, what do they give you here? They give you the length of this side, which here's your 30 degrees, so this has to be 60. And by the way, they're never going to give you both of those angles. They only will give you one of them, and you have to know that if they give you that 30 degrees, it's a 30, 60, 90 triangle. Okay? So if this side is across from 60, that's your long side. So here's your short side. Short, hypotenuse, there's your long side. So we're going to have to do the opposite operation of multiplying by 3, which is dividing by the square root of 3. So this is nice because when you divide 3 square root of 3 by square root of 3, those square root of 3s are just going to cancel, and you'll get the short side is 3, and the hypotenuse will be 6. Okay? This one, you're given the hypotenuse, so that's your 2. Here's your 30 degrees, so that's your 1. And here's your square root of 3. So we're going to cut this in half to get x, your short side, so that will be 5, and then this will be 5 square root of 3. We done? We're done. Ah. Peace out.
Thank you.